2024 A-Level Combined Mathematics Paper 1 Part B Question number 11 Part A. This question has to do with quadratic equations. The question says, let fx be equal to x squared plus 2x plus c, where c is an element of the real numbers. It is given that the equation fx equals 0 has two real distinct roots. Given this, we are asked to show that c is less than 1. After this, it says, let alpha and beta be the roots of fx equals 0. What this means is that if you take alpha and substitute it into fx, f of alpha is going to be equal to 0. And similarly, if you take beta, f of beta is also going to be equal to 0. But alpha and beta are not equal to each other since the two real roots are distinct. Given this, we are asked to show that alpha squared plus beta squared is equal to 4 minus 2c. And then finally they say, let c be not equal to 0 and lambda be element of the real numbers. Given this, they say the quadratic equation with alpha plus 1 over alpha and beta plus 1 over beta as its roots is given by 2x squared plus 12x plus lambda equals 0. Now with this information, we are finally asked to find the values of c and lambda. So to start off with this question, the first thing you need to do is to consider the function fx equals x squared plus 2x plus c. Consider fx equals 0 and use the information that fx equals 0 has two real distinct roots in order to show that c is less than 1. So to start off, we have fx, function fx equals x squared plus 2x plus c. And we have to consider fx equals 0. Now in this situation, we can see fx equals 0 equates to x squared plus 2x plus c equals 0. And we are told that this has two real distinct roots. Now the roots are determined mostly by the determinant, which is delta, which is equal to b squared minus 4ac in a quadratic equation of the form ax squared plus bx plus c equals 0. Now in this case, we can see we have a x squared, bx and c, where c is c, but a is equal to 1 and b is equal to plus 2. And therefore, if we substitute that into delta, we can see delta is going to be equal to b squared, which is 2 squared, minus 4a, which is 1, times c, which is c. And then if we simplify, we're going to get 4 minus 4c, which is going to be equal to 4 times 1 minus c. Now here, we are told that this equation has two real distinct roots. Now if the roots are real, it means that delta is greater than or equal to 0. And if they are also distinct, as we discussed in our lesson on quadratic equations, we know that delta must definitely be greater than 0. Because if delta is equal to 0, then our roots are real, but they are both the same exact root. So therefore we can say, if the above equation has, and we'll underline, real distinct roots, we can say therefore delta is going to be greater than 0. Since if delta is equal to 0, we'd have real roots, but we wouldn't have distinct roots. So therefore we can say if delta is greater than 0, then 4 times 1 minus c must be greater than 0. And therefore if we divide out the 4, we are left with 1 minus c greater than 0, leading us to c less than 1. If you take c to the other side, we can see 1 is greater than c, and therefore c is less than 1. So with that, we have concluded that c must be less than 1 if c is an element of the real numbers, and the quadratic equation that we have here has real and distinct roots. Now moving on to the second part, after this we are told that alpha and beta are the roots of fx equals 0. Now when we have something where we have two roots, alpha and beta, we can say the quadratic equation that's going to have the roots alpha and beta is given by x minus alpha times x minus beta equals 0. And if we expand this, we can see this expands out to x squared minus alpha plus beta x plus alpha beta equals 0. Now as we know from theory, if this is equivalent to an equation ax squared plus bx plus c equals 0, where a is not equal to 0, then we can see minus alpha plus beta must be equal to b divided by a, because if you divide everything by a, you're going to get x squared plus b over ax plus c over a equals 0. And here we can see, since the coefficient of x squared now is equal and these two equations are identical to each other, this coefficient must be equal to this and this coefficient must be equal to this. So from theory we know alpha plus beta is going to be equal to negative b over a and alpha beta is going to be equal to c over a. So we can apply that theory here and say if alpha and beta are the two roots, if alpha comma beta are the two roots of fx equals 0, i.e. x squared plus 2x plus c equals 0, if they are the roots of this equation, then we can say alpha plus beta is equal to something and alpha beta is equal to something. Now from our formula, alpha plus beta is equal to negative b over a, where b is the coefficient of x and a is the coefficient of x squared. In this thing we can see the coefficient of x is equal to 2 and the coefficient of x squared is equal to 1. So therefore we have negative 2 over 1. We can write negative 2 over 1, which is equal to negative 2. Now considering alpha beta is equal to c over a, where c is the constant term and a is the coefficient of x squared. Now in this equation, c is actually equal to c, since the constant term is itself also c, it's the same symbol. But the x squared term's coefficient is 1, and therefore what we have here, c over a is c over 1, which is just c. And therefore, alpha plus beta, which is the sum of the two roots, is equal to negative 2, and alpha beta, which is the product of the two roots, is equal to c. Now we're going to call this equation number 1, and we're going to call this equation number 2, and we're going to use 1 and 2 in order to find what they want, which in this case is alpha squared plus beta squared. Now note, if you take alpha plus beta and you square it, you're going to get alpha squared plus 2 alpha beta plus beta squared. Now there, in the middle, if we remove the 2 alpha beta term, we're going to be left with alpha squared plus beta squared on the left hand side, which is exactly what we want here. And we know alpha beta can be replaced with c. And therefore what we need to do is to take equation 1 and square it as such and write alpha plus beta squared, and on the other side we're going to have minus 2 squared, and simplifying we get alpha squared plus 2 alpha beta plus beta squared equal to, and negative 2 squared is equal to 4. Now here we can see if we take alpha squared plus beta squared on its own and isolate it, we're going to have 4 minus 2 alpha beta, and as we know alpha beta is equal to c, and therefore if we take equation 2 and substitute into this expression, we get alpha squared plus beta squared equal to 4 minus 2 times alpha beta, which is c, so minus 2c, and therefore equation is alpha squared plus beta squared equal to 4 minus 2c. And with that we have shown the second condition, alpha squared plus beta squared equals 4 minus 2c. Now finally, we are asked to take c as being not equal to 0, lambda as being a real number, and given this, we are told that the roots alpha plus 1 over alpha and beta plus 1 over beta, when turned into a quadratic equation, will give the quadratic equation 2x squared plus 12x plus lambda equals 0. And given this, we are asked to find the value of lambda and c. So considering this entire thing, alpha plus 1 over alpha, is one of our roots. So here this value is alpha, and if we substitute that into here, this whole thing is going to be a certain value which I'm going to call alpha dash. Similarly, this whole thing is going to be another value which I'm going to call beta dash. And alpha dash and beta dash are the solutions to 2x squared plus 12x plus lambda equals 0. Meaning if you substitute alpha dash for x, you're going to get 0. And if you substitute beta dash for x, you're also going to get 0. Now considering that, we can see, given this, similar to what we did for alpha and beta in this expression, we know if you have the sum of the two roots, alpha plus beta, it's going to be equal to negative b over a, where b is the coefficient of x and a is the coefficient of x squared, and alpha times beta, the product of the two roots, is going to be equal to c over a, where c is the constant term and a is the coefficient of the x squared term. So given this, we can say, if we go down, we'll write if alpha plus 1 over alpha and beta plus 1 over beta are the roots of 2x squared plus 12x plus lambda equals 0, then we can say the sum of the two roots must be equal to negative b over a, and the product of the two roots must be equal to c over a, or lambda over 2. So therefore we can say alpha plus 1 over alpha, which is the first root, plus beta plus 1 over beta, which is the second root, is equal to b, so negative b over a, which is negative 12 over 2. Negative 12 over 2. This is equation number 1. And similarly, the product of the two roots, which is going to be alpha plus 1 over alpha, times beta plus 1 over beta, is equal to c over a, which is going to be lambda over 2. So lambda over 2. This is going to be equation 2. Actually, we should probably write this equation number 3, and this is equation number 4, since we already used equation number 1 and 2 up here. So now we have equation number 3 and equation number 4. Now considering this, if we take equation number 3, we can see, simplifying both sides, on the left hand side we have alpha plus beta, but we also have 1 over alpha and a 1 over beta. Now since we don't know 1 over alpha and 1 over beta, what I'm going to do is to take them under common denominator of alpha beta. Now take both of these under common denominator of alpha beta, we need to multiply the top and bottom here by beta and the top and bottom here by alpha. Doing so, we can see we get beta over alpha beta plus alpha over alpha beta, which when you add together is going to be equal to plus alpha plus beta divided by alpha beta. On the other side, we can see negative 12 over 2 is equal to negative 6. So therefore we have negative 6 on that side. Now considering the stuff here, we can see we have alpha plus beta, and alpha beta. Going up, we can see we know alpha plus beta and alpha beta in terms of numbers and constants. So therefore, we can substitute equation number 1 and equation number 2 and get rid of all the alphas and betas in this equation and have only numbers and constants. So doing so, if we use 1, 2 and we substitute into this, we're going to get alpha plus beta, which is equal to negative 2, and alpha beta is equal to c. So we're going to get negative 2 plus negative 2 divided by alpha beta, which is c, equal to negative 6. Now considering this, we have negative 2 over c, and if we take this negative 2 to the other side, we have negative 2 to the other side, which is going to be positive 2, minus 6, and plus 2 minus 6 is minus 4. So therefore, this is minus 4. Now here we can see if we swap these two, we're going to get c equals minus 2 divided by minus 4, which is a half. Therefore, c is equal to half. We have found c. So now, all we need to do is to find lambda, and we'll be done with this question. So to find lambda, as you can probably guess, we need to use equation number 4. So considering equation number 4, if we take it and we expand it, we can see equation number 4 is going to give us this expansion, which is going to be alpha times beta. So we can write alpha beta, and then alpha times 1 over beta, which is going to be alpha over beta, plus alpha over beta, and then 1 over alpha times beta, which is going to be beta over alpha, so plus beta over alpha, and finally 1 over alpha times 1 over beta, which is 1 over alpha beta, plus 1 over alpha beta, and this is equal to lambda over 2. So now with this, we can see if we take the 2 to the other side, we have lambda directly in terms of alphas and betas. What we need to do now is to simplify this down into expressions that we know and then substitute and get the answer. So considering this, we know alpha beta here and here, no problem, but we don't know alpha divided by beta and we don't know beta divided by alpha. But what we can do once again is to take these two terms under a common denominator of alpha beta and simplify. So doing so, we can see we have alpha times beta, and I'll take the 1 over alpha beta 2, and then we have alpha divided by beta plus beta divided by alpha. The common denominator here is going to be alpha beta, and if we multiply this thing, the top and bottom need to be multiplied by alpha, which is going to be alpha squared divided by alpha beta. And then here, the top and bottom need to be multiplied by beta, which is going to give us beta squared divided by alpha beta. Therefore, we get a common denominator of alpha beta, and the numerator is going to be alpha times alpha, which is alpha squared, plus beta times beta, which is going to be beta squared. and this is equal to lambda divided by 2. Now, we know alpha beta, and alpha beta, but we also know alpha squared plus beta squared. We know it because we were asked to prove it all the way up here. We know alpha squared plus beta squared is equal to 4 minus 2c. So now what we can do is to go down and substitute all of these things, and we can say substituting equation number 2, and we'll name this something. We'll call this equation, let's say A or something. Substituting equation number 2, which is alpha beta, and equation A, we can see we're going to get equation number 2 and equation number A, we're going to get C plus 1 over C plus 4 minus 2C divided by C equal to lambda divided by 2. And now what we can do is to substitute it in C. So we know C is equal to half, which we'll call equation, let's say B or something. And we can see if we substitute B, then we're going to get rid of all of the symbols other than lambda here, and we're only going to have numbers. So therefore, if we take equation B and substitute, and I'm going to take the lambda on one side, let's say the left hand side, we're going to get lambda equal to 2 times, and then on the inside, C is equal to half, 1 over C is equal to 2, 4 minus 2C is going to be equal to 4 minus, and 2C is equal to 1 since C is equal to 1 over 2, therefore 4 minus 1 divided by C, which is divided by a half, and that is our expression for lambda. So now if we simplify, we can see lambda is equal to 1 plus 4 plus, and here we can see we have 3 times 2, since dividing by half is multiplying by 2, so 3 times 2 times another 2, which is 3 times 4, which is 12, so plus 12, and we can see we have 12 plus 4 plus 1, which is 16 plus 1, which is 17, and therefore lambda is equal to 17. And with that, we have solved the entirety of question number 11, part A. Now finally, let's discuss the marks scored for this question. So at the start, when you consider fx equals 0 and you obtain that delta is equal to b squared minus 4ac, which in this case is 4 times 1 minus c, when you get either here or here, you get 5 marks. Now after this, when you say if the above equation has real and distinct roots, then delta must be greater than 0. For getting that result, you get another 5 marks. After this, when you simplify down to get that c must be less than 1, you get another 5 marks. Now for the next part, when you say if alpha and beta are the two roots of fx equals 0, then alpha plus beta is equal to negative 2 and alpha beta is equal to c. For getting this equation, you get 5 marks. And for getting this equation, you get 5 marks. Now after that, when you take this thing and you square alpha plus beta to get alpha squared plus beta squared, and you obtain this expression right here, you get 5 marks. And after that, when you simplify, substitute in alpha times beta as c, and then get this expression right here, you get another 5 marks for that. Now after this, when you consider the other two roots of the other quadratic equation, alpha plus 1 over alpha and beta plus 1 over beta, when you realize that you can once again do the sum of the two roots and the product of the two roots, and you write down this equation for the sum of the two roots, you get 10 marks. And similarly, when you write out the product of the two roots like this, you get 10 marks for that. After this, when you use the sum and product rules, for the sum rule, when you sum them together and you write this equation by simplifying these two brackets and getting alpha plus beta and taking the common denominator of the other two as alpha beta and writing alpha plus beta divided by alpha beta and getting this equation right here, you get 5 marks. After this, when you substitute in alpha plus beta and alpha beta as such to get this expression right here, you get 5 marks. And then when you simplify down to get c equals a half, you get another 5 marks. Now similarly, for the second part, when you use the product rule like this, and you simplify down the brackets by expanding them to this, and then you also convert alpha divided by beta plus beta divided by alpha into alpha squared plus beta squared divided by alpha beta, for writing this expression right here, this line, you get 5 marks. After this, when you substitute in the values of c like this by first simplifying alpha betas and alpha squared plus beta squared to this expression, and then substituting c to get this expression right here, getting this expression gets you another 5 marks. And finally, simplifying down to get that lambda plus, oh, I made a mistake here. It appears I've written lambda again as the answer instead of 17. So anyway, here we have 17, and getting the final answer of lambda equals 17 gets you another 5 marks. That's a little silly mistake by me, I apologize. Anyway, when you get lambda equals 17, you get another 5 marks. And that is the end of this question. So I hope you enjoyed. If you have any feedback, post them in the comments down below. Thank you for watching, and goodbye.